This video will show you how to do a low-level global keyboard hook in C#.net. This would work at VB.net too, of course, but my language of choice is C# in this tutorial. So this will be demonstrating just a very quick WPF app that will exemplify the use of a low-level keyboard hook in Windows using C#.net. It's written about on my blog here. You can get the code here for the example we're about to do. And let's see. So dylansweb.com page 207 is the low-level global keyboard hook /sync in C#.net post. And this is the app back here. Just a desktop application in WPF. Simple form with a text box on it. The text box is simply going to display everything we press on the keyboard, and nothing fancy. Just going to be pasting out or writing out basically the two-string representation of the key enumeration value that is returned by the function that we see in here, a class called low-level keyboard listener. So we have our window class, very simple. We have the actual meat of the matter, which is what you're after if you're looking at this video for inspiration into how to reliably get keyboard input regardless of focus, regardless of desktop Z order, etc., etc. And this is the window, the XAML or design view of the app. So the first thing you want to do, of course, is you want to know what you're dealing with. And in this case, we're using a few functions out of the user32 DLL. You can see those here. So the signature that we want, of course, we're going to find on pinvoke.net. Just, basically you can Google the function name if you already know what that is, and you'd find it here on pinvoke.net. You'd want to visit the MSDN article first and take a look at what the parameters are, what you're dealing with, what the MSDN documentation has to say about the method and how to use it, etc., etc. All very good information, stuff you want to know, stuff you want to go through. As tedious as it may or may not seem, copying and pasting and slapping code around is not a good idea if you don't understand what's there. So take a read timeout for yourself and have a look at the article that goes along with each of the methods you'll be putting to use. And in this case, we'll be putting to use what? 1, 2, 3, 4. 4 different types of methods, 4 methods, I should say, out of the user32 DLL. DLL import attribute is applied with the private static extern signature, which we, of course, scraped and or grabbed from here. Now, if you don't know about pinvoke.net, you ought to. It's the go-to place on the web for the signatures and descriptions of everything you might want to use from the low-level libraries available in the Windows SDK while working in the .NET managed world. So again, read about your methods, go get your signatures here, set them up inside your code, and boom. What I have here is a class which is going to make it very easy to do what we want to do, which is to listen to the keyboard input at a low level, below your application, below the other applications on the desktop, below the .NET framework itself. Right down at the native Windows level, you want to be listening for the input from the keyboard so that you can reliably capture it regardless of what's going on the computer where you're running your app. So you have your methods set up, and here you just see a hook, a callback, and I've set up an event called key on key pressed, which just has a simple argument class or type which contains a key of the key enumeration of system.windows.input. Get that tooltip up there. There you go. System.windows.input.key is the enumeration. And so we're just going to package the code returned by the key press from Windows into this argument and fire it off in the event every time a key is pressed on the keyboard. And as you can see by the by the hook callback method, What we actually get is a virtual key code from Windows. Now, if you don't know what virtual keys are or what virtual key codes are, you can see that here. Virtual key codes, fully explained by MSDN. There you are. But all you need to know for this purpose is how to convert it to a key, or at least in the case of this class. So we're using something from key interop, called key interop, I should say, a method out of that type called key from virtual key. So we pass the VK code in, the virtual key code in, which is an integer, and we get back a key enumeration value. This I throw into the constructor of the key pressed args type, and the event is broadcast, and any listeners will then receive the key presses as they occur, which in this case is happening inside of our main window. You can see I have a private instance of the low-level keyboard listener type we have here, and I subscribe to that event in the window loaded event of the window, and then I use the method called the hook keyboard on that type to start listening to the keyboard. You'll notice that in window closing I call unhook keyboard. You could do this however and whenever you like. Don't forget it's generally a good idea to want to unhook once you've hooked. And then, well, we subscribe to that event, and then we are just simply taking the argument of the event and calling toString on the key enumeration value that comes from the event, and just appending that to the text box text property in the window we have here. So, taking a look at the Solution Explorer, we can just run build and then click start, and we have this window here. Okay, it's marked as read only, so what I'll do now is just open a notepad and start typing. This is something I am typing, and you can see again it is literally key for key pasting out exactly what I type, no matter where I'm typing it. If I'm on the desktop and I hit the R key, well, there you go. If I'm in Notepad and I hit the R key, well, there you go. If I'm in my code and I start hitting stuff, Visual Studio doesn't like it, but I still get it. And there you have it. That's it. You can read all about it on my blog. It's the latest entry, October 5th, 2014. Enjoy.